Welcome to Critical Thread. Over the next hour, we will dive deep into manufacturing with Rachel Lecrone.
Rachel began her career in manufacturing as a controls engineer in heavy-duty engine assembly. Throughout this 25-plus year career, she's held various roles in manufacturing engineering, operations, plant management, supply chain. She's got extensive experience with manufacturing execution systems. She launched a Manufacturing Industry 4.0 initiative that was aimed at applying the latest digital technology to transform manufacturing operations. She seems to really enjoy applying new technology to tackle longstanding manufacturing problems.
And without further ado, as they say, what I love about this one is that we are coming out of the manufacturing floor and we're actually connecting ourselves back into those earlier stages in engineering. So we're going to be covering the MBOM, manufacturing process planning, change management, and of course, execution, or specifically within the industrial equipment sector. Ready, set, let's go.
Hey, Rachel, welcome to the show. Thanks for joining us today.
Hello, thanks for having me.
We just heard all about you as far as your career, but let's just say we happen to run into you in an elevator and we say, hey, who are you? What's your response?
Who am I? I am a manufacturing engineer and a manufacturing operations leader first and foremost. I've spent my career in manufacturing and I get very excited about digital technology, and it's been wonderful to watch how technology has evolved over the last 20 years. It's just taken what we imagined 20 years ago and made it into a reality that we can apply directly on the shop floor. And, it's just such an exciting time to be in manufacturing. And I'm happy to say I've made a career of being at the forefront of that and working with manufacturing teams to put that technology to good use on the shop floor.
I'm with you on that one, Rachel. I'm just going to jump in because I think we've spent billions on the whole design and engineering aspects over the years. But I think today is the day where manufacturing is really starting to put some money into it, really investing, as you say, in digital technology. So it's a great time to be in manufacturing.
It really is. Engineering has used tools like simulation, finite element analysis, really taking computing a long way and applying models and things to the design of products. And now we're doing the very same thing in manufacturing to our processes to figure out how do we optimize those processes? How do we get the most in terms of productivity and quality out of them? So it's a really exciting time.
Great.
It does sound like you are really excited about manufacturing. I'm curious, how did that happen? Like, what was it that took you down this path?
It was a little bit accidental. I was hired right out of college into a manufacturing shop floor role, and it was with a company that gave a lot of freedom to explore and try new things. And that coupled with my background in electrical engineering, it just dovetailed, and I was in a great place to experiment and try new things, and in a company that rewarded innovation and really let that dictate how my career went. So really appreciative of that.
So can you give us, let's just say like a brief overview of MBOM and why it's significant in the industrial equipment sector?
Mm-hmm. Sure. So an MBOM is a manufacturing bill of material. In its simplest form is really a copy of the engineering bill of material. It's got a list of the parts that are going into the product you're going to make. It has the name of those parts, the part number, the quantity. It can have some other processing information or specifications attached to it. But in manufacturing, typically you will add some things that are unique to the manufacturing process that aren't as critical from a product engineer perspective. So a manufacturing engineer will take that MBOM, that bill of material, and make it their own. They will add things like masking or lubricants, odds and ends that are critical to them that they have to plan very carefully, packaging materials, that sort of thing. And then, you can take it a step further into the service realm. Service may have their own unique requirements for the bill of material that differentiate it from the prior two, but it all stems from that original product bill of material.
Yeah. I like the way you're kind of emphasizing the detail and that kind of comprehensive scope of MBOM. Your part information, your process details, etc., etc. I think what it is doing, it's kind of underscoring the critical role of the MBOM as a blueprint for manufacturing, not just in the industrial equipment sector, but in many sectors for that matter. I think it's the emphasis on that completeness, the accuracy, which I think is particularly relevant today, because not only does industrial equipment operate in a heavy engineer to order environment, but most sectors now are getting heavily involved in personalization, customization, etc.
Mm-hmm.
So I think, as you say, it's that level of detail that you need, that blueprint in the MBOM.
It's very critical. And especially in a lot of the heavy industrial applications, you don't always have a product print to follow. So some industries still build off a print. Some don't have time to develop detailed prints with annotated drawings and so forth. So you may be building your product from that MBOM. It may be the minimum information you need to do that work.
Yeah. And how do you find companies typically ensure the accuracy of an MBOM, given that high level of variation and customization that we're seeing more and more these days?
Well, number one, it has to start with, again, the product bill of materials being correct, but accuracy, you can measure it, you can audit it.
Right.
And a lot of best practice companies do audit their MBOMs for accuracy, but you can also need to measure quality in the plant floor. So if you have a lot of disruptions to your process because there are errors on the bill of material, and tying back those disruptions to errors, that is a measure of the accuracy of the MBOM. That's actually one of the best ways to figure it out, is when things get to the floor and the operators have the information to do their job, everything flows smoothly. If there's a hiccup, if they have a part called out and the part isn't there, or if they're trying to assemble something and it's not going together, or they have the wrong quantity, they're going to figure it out 9 times out of 10. And that 10th time, it may be your customer figuring it out. So you also have to look at customer quality and pay attention. And so the impetus is on the manufacturing engineers and the product engineers to keep those bill of materials accurate, so that you don't have the disruption to the shop floor, and you certainly don't have issues getting to your customer.
Yeah.
So it sounds like, or we know that the MBOM relates. A lot of things are supposed to play nice with it: the specs, the prints, the process plan. And so when the MBOM is wrong, a lot of other stuff can go wrong, right? So what are the most common challenges that companies have when they're trying to create MBOMs, to manage MBOMs?
Number one, you have to have a good change management process. So, it's one thing to get the BOM right, but it's very rare that products stay static. So especially in very complex assembly operations, where you're building a complex piece of equipment with a very detailed bill of materials, it's got to be accurate. And the change management process is going to take in the inputs of all of those different organizations. It's going to make sure that the materials teams can have their materials there on time, those parts there to build. It's going to make sure that the manufacturing engineers have any tooling or any equipment that needs to be a part of that process to build that product there. And then, it takes into account too, when did you tell the sales team that they could alert the customer that this is going to be ready? So we can't start selling something if we can't get the parts and we don't have a process ready to build it. So it really ties all of those things together. And change management, especially in the day and age of COVID and all of the supply chain disruptions that drove with that, it was absolutely critical, because in a lot of these complex processes, you may have to make substitutions or changes to your bill of material because you can get this part, but you can't get that part. So you have to be able to be agile. So, typically in the company I work for, we had processes that would change at 10 a.m. on Tuesday a new set of parts would go in. And so a revision to the bill of material had to take effect at that date and that time. And they had all the teams lined up to make the change and get the new tools and change out materials on the shop floor so that change happened on that minute. And then we've had other processes that did a model year changeover. So on September 1st, stop using the old parts, start using the new parts, and then everything is static until you get to September 1st of the following year. So it just depends on what kind of environment you're in, what your product is, and the level of complexity you're dealing with.
Yeah, yeah. I mean, with the complexity you talked about, you're right, but slow change management process has got to be just the nightmare on the manufacturing floor. I mean, you can't help yourself. Surely you're just going to bypass procedures. You're going to compromise completeness because upstream the change is just dreadfully slow. I mean, how do you handle that?
Well, a couple ways. Number one, if you have a good change management system and a good change management process, and they're two different things, and they need to be tailored to each other, you can manage it. But what I've seen is where either the process has unnecessarily complex rules, meaning you need 20 signatures to get a change through and it takes 3 months to do it, but you've got to build the parts tomorrow. People will work around the process and they will start to make changes outside of it. And, I've seen whole processes where people built a side database to handle their bill of material that they were actually building that sat next to the one that they were supposed to be building. And if you let that go on too long, what you're building is out of control and you don't really know what that is. It's all in some other space. So it's very important to have an accurate change management process and that it's agile enough to handle the degree of change that you've got in your product.
Do you have any kind of 1, 2, 3 steps that you would take to help streamline that change management process?
I think you need to know what type of product you're building, and it needs to be tailored to that. So if you have a very simple product, you don't need to go overboard and have a crazy complex change management process.
Yeah.
In some cases, customers have a very detailed say. I had a process that I dealt with in one plant that we were contractually obligated to get the customer's sign off on any time. I couldn't move a piece of equipment 2 inches to the left without the customer signing a PPAP change. That's a part of the change management process. I have other plants that had a lot more freedom and needed that degree of freedom to keep up with the pace of change, because it was fast and it was furious because they were building one-off products. So, builds in units of 1 to an order of 500 products a day. Kind of a crazy degree of proliferation, but that was the value we gave to our customer. So it was necessary that we were good at it.
Yeah.
So having an accurate MBOM, having a complete one, having one that stays up to date with changes seems really important. What do you think are the effective key components to have an effective MBOM?
So accuracy and completeness, we've been talking about that. Your EBOM has to be accurate and complete. So the information you're getting from engineering, so you need to measure that. And, one way to measure it is, again, how many deviations do you have against it? Because we used to put in temporary changes until the formal changes were go through, because you may have something that you want to change just for a short period of time. So measuring, how much of those type of little tweaks you're making to it over time. And, is the level getting worse or is it getting better? Is it high when you launch and tapering off to a nice slow rate? That might be one thing, or it may just get worse and worse as you begin to introduce variations. So being able to measure that and understand it. Again, having a good, robust change management process is the other piece. So how often are you able to implement changes on your target date? Is your material ready? Is your engineering ready? What groups are getting their work done, which ones aren't? And typically, if a group can't get their work done, it may not be because they're not trying hard. It may be because they're understaffed. They don't have the right materials. There's huge disruptions in the supply chain that aren't being considered, or they can't purchase equipment. Supply chain disruptions affected both the materials teams and the manufacturing engineering teams through the COVID years. So really taking those things into account and understanding the impact of those is going to have a piece to play in that.
Couple of things, Rachel. One, have you? Every day we walk into our customers and we find siloed embalm, manual build of an embalm, even though
Hmm.
the embalm may be kind of synced up and bi-directional, but it's not connected with the ERP, which is where they think the embalm's going to be kind of reside and built out from, which I appreciate. We see that. Have you worked in that kind of seamless, even if it's one way, not necessarily two-way environment, where that CAD EBOM is integrated with embalm and then that pulled through into manufacturing? Have you worked in that digital environment?
I haven't. I've been fortunate to work for a company that had a lot of IT resources, and
Yeah.
so we were actually in a mainframe system with our bombs and had a pretty robust
Yeah.
data flow of data and a good change management process around that mainframe. But it was very well tied to our product structure and tailored very deeply to how we built product.
Right.
But we would pull those bills of materials. They would flow into the ERP systems and they would flow into the MES systems directly.
Right.
There's still a lot of work to do in those downstream systems because as you flow that through, each group is going to add their content to that bomb. So the
Yeah.
materials teams add their supplier information and delivery information, and where are they going to store these parts, where are they going to deliver them on the line. All of those details get filtered in as part as their process plans. Likewise, manufacturing engineering fills out their process plan.
Mm.
But it's been done for a very long time, and some companies have gotten very, very good at it. The
Yeah.
good news is that with the new systems that are coming out, the newer PLM systems, they're designed to take a lot of this into account. And if you can stick to the way those systems are designed and avoid customizing them, they've got some great tools for moving those that information seamlessly
Yeah.
through each stage of the product life cycle.
Yeah, yeah. No, we're big proponents of don't break the thread. So if you're going to put it into your EBOM, get it synced so it's into your
Mm-hmm.
embalm and it's going into your manufacturing.
Yeah,
Absolutely, easier said than done. But
it
it's,
is.
when the magic happens, it's great.
So you already mentioned that it's that some of the BOM management really depends on your level of complexity with your product and maybe what's happening at your work site and company. Can you elaborate a little bit on what you mean by that?
Well, like I said, the complexity, if you're building a simple part, take a fuel filter or something like that, you've basically got a can, you've got your materials, you've got a cap that's going to go on it. And there's a handful of parts, and you don't need a lot of complexity to manage that bill of materials. If you're in a configure to order, it can get much more complex. You may have a much more complex part, a lot more part numbers to manage. And, they may come in different groups or subassemblies. You have to think about the structure. So you can't have a flat bomb. You now have a structured bomb. And then if you're in the engineer to order phase, our type of product, you're going to write a new bill of materials essentially for every single order that comes in. So you have an engineer figuring out and doing a new design for that customer. So they're going to hand off a new bill of materials. And so that's where it's actually probably the trickiest and most critical. And really planning out how you're going to align your product with what you're delivering to your customer is important. I worked in a factory that was building a new product, and it was a new technology that was needed to meet in engine emissions. And the original way we designed it, we went to our customers, said, "What do you need? What do you want it to look like?" And they came back and gave us 1,000 ideas. And so when I moved into managing that plant, we had a wall of fixtures to build this product 1,000 different ways. Our product engineering teams and manufacturing engineering teams learned a lot from that experience. And so when they revised the product 3 years later, they went to the customers and said, "Okay, we're going to give you these options. You can have a straight in, a straight out, a side in, a side out, and then we'll rotate them 180 degrees." And so we went from wall of fixtures to a compact product with a few variations, maybe 10, 12 inlet outlet kind of variations, and a few other designs, but much, much more manageable, but for us and for our customers. And so thinking about those kinds of things and the impact that product design is going to have on the complexity of your supply chain, on the complexity of your manufacturing process, it really ripples through. But it has to start with the product design.
Speaking of thinking about things, so process plans, how does that work in conjunction with an MBOM, specifically with contributing to being efficient in manufacturing operations?
So the process plan is really the domain of the industrial and manufacturing engineer. And this is where they are going to do their most important work. They will get a product design from product engineering, and the product engineers may have spent months and years designing every aspect of this product. The manufacturing engineers have to figure out how to make one a minute for the next 5 years. And so it's a different challenge, but it is a very big challenge, because how you do that, how much you automate, how much is manual work, how you split that out into workstations or work cells, depending on how your product is arranged or manufactured, is really critical. So the process plan is really where they're going to do their work. So what you do is you can take your EBOM and your product specs and the process design. You got your process plan. You'll lay out your sequence and according to how in what order you're going to perform operations to build that product. From there, you can design each workstation for your operators. You'll get into the industrial engineering studies for time analysis. You'll look at resources and tooling allocation. And then the process design can also look at the higher level plant design. So you can look at your plant and how does material move between cells in your plant or product lines in your plant, and how do you pull materials in, ship materials out, and lay out a whole plant. And then it can get into other areas like design for ergonomics, because once you know what operator is going to do that work, you have a responsibility to ensure that they can do it safely and effectively. So looking at the ergonomic aspects, is the part too heavy? Do they need a lift assist device? Is there a sharp edge that they're going to get their hand caught on? Do they have access to put the cap screw in where they need to put the cap screw? All of those things kind of factor into that. So all the central boxes there are really the domain of the manufacturing engineer, and they are going to take that bill of materials and add a whole lot of information tailored around it that's going to describe that full process from end to end.
Can you provide an example? I mean, because through the years you've seen not very detailed process plans and then detailed process plans. Can you provide an example of where a really detailed process plan has directly contributed to improvements in manufacturing efficiency or product quality?
Definitely. We've seen examples where we didn't have enough of a detailed process plan and actually didn't take things to the point of actually simulating those processes. And I think simulation is a great, very powerful tool if you use it right. You can waste a lot of time with it, but if you do it right, it can give you insights that otherwise will take you months to figure out, or years to figure out and tweak. We've seen instances with simulation where I had one in a plant that I managed where we didn't simulate a process because we didn't really have the tools available at the time. This was many years ago. And put a process in. We were moving parts around in work cells robotically, and we could never figure out why we were only getting a fraction of the productivity out of this work cell. And everything on paper looked good, and I took my controls engineer down there, and we just stared at the process. And what we discovered was, after watching this process, and it was always moving, there was always something in motion, and a machine doing its welding, and it was just humming right along, but the productivity wasn't there. What we discovered was we had 4 workstations and a pass table, and we had 4 parts in process. So there were always 4 parts sitting somewhere, but 5 places they could sit. So one was always empty. So you immediately cut your productivity by 20% right off the bat. And so we had to, once we recognized, if we'd simulated that, we would have found it. We put it into production, and we found it the hard way. And then it took us some time to reprogram everything to get that extra part in there. And then our productivity bounced right back up. So it's an idea of how you lay that process out. It is really important.
Great example. And I've got one I'm just going to touch on briefly, which is, have you seen the kind of impact that going through to work instructions started the 3D CAD going into the work instructions? Have you seen that have an impact in manufacturing as well?
Yeah, absolutely. We were really starting to push that one in my most recent role, and what we saw is the 3D CAD just gives you so many options in terms of creating work instructions. You know, the old way of work instructions where you would have an alpha build or beta build. So you would have real prototype parts and you would be assembling them, and you'd have to send somebody down onto the shop floor with a camera, start clicking pictures of the operators and how they're putting things on. And so they're trying to do their job and you're trying to take pictures of it. And, everybody's tripping over each other.
Yep.
And then you have to go back and edit them and everything. And with the 3D CAD instructions, you can position everything. You can hide what components aren't relevant. You just have all the powers of that CAD program. And then you can integrate your CAD models for your equipment, your conveyors, your robots, your tooling. You can put mannequins in there to show the operators. You can even automate those mannequins to show, here's how the process of how something's going to go together. Here's the motion you need to use to move it in place and so forth. So it's a really powerful tool, and you can do it in a fraction of the time that the old camera method took.
Yeah, great. Thank you.
We've been talking about a lot of how this kind of works maybe in pieces, but if we look at the idea of integrating your whole PLM system with EBOM, with change management, with the manufacturing process, with transitioning data from PLM to the shop floor, what best practices do you have for us?
I think one of the first is that PLM system owners need to understand that this system is going to be used by multiple groups. You need to have multiple stakeholders in the party as you're setting up these systems and the surrounding processes. So it's important that everyone comes to the party with resources and the ability to really think through what should that process and what should those data flows be, what should that change management process be, because product engineering has one thing they want to get out of a PLM system. And they're typically the owners of these systems because that's where all this data is originating. Manufacturing has distinct needs they need to get from it too. And service has slightly different needs that they're going to need, as well as materials. So all of these groups need to kind of come together and work together on a process. And they need to understand each other's limitations and each other's requirements. The other things I'll say is you're never going to optimize it for everyone. So it's almost more important to not customize it to a huge degree, because I've seen that go very, very wrong. And I've seen companies spend a lot of time trying to get rid of customizations that they were sure they needed, and then they figured out they really didn't need. So it's better to just avoid those on the front end. And you better have a darn good reason, like we're doing business in a country that has some government requirement that the only way we can meet it is with this customization. So there's reasons for them, but it's best to avoid them. And that being said, not all PLM systems are good for everyone. I've seen companies use very simple ones that they outgrew. So you just need to be aware of where you are as a company, where your sales numbers are, and how are they going up? How are your products changing and evolving? And just make sure that you have a plan if you need to move on to something that's more complex and more capable, that you have a plan to do it before it starts to cause major disruptions in your supply chain.
Yeah. One of the things that's really kind of driven home for me while we've been talking is you've really explained and extolled the virtues of pulling change all the way through to manufacturing. A lot of the times we find environments where change just sits in PLM, but from a PLM application perspective, it doesn't get pushed all the way through into manufacturing. And I think what you've done is really said that holistic approach in the PLM integration piece is just critical for manufacturing to operate efficiently, productively, etc. So we don't see enough of it, I'll be honest. So how do you suggest companies navigate the differing needs, so to speak, of engineering, manufacturing, and even the service departments when integrating that product lifecycle system?
There's a couple different ways to do it. You can either have all of them working from the exact same change management process. You can have parallel change management processes, and that's something we had typically done. Or you could have a handoff from one process to the next What's most important, though, is to know who is in charge of timing the change. Who's the one, which group or which person in your organization or which system in your organization is going to say this change is going to take place for this product at 10 a.m. on Thursday, because that message needs to get out to all of those other groups so that they are in concert and they have their work done and are ready to go at that point in time. For us, it typically fell in the materials organization. They were kind of sent to a lot of that, but that doesn't necessarily mean that that's how it should always be. It really depends on how your company works, how your process flows. So again, change management is important, and you need a process that's good enough and detailed enough to meet each company's needs. So if you're going to try and move your manufacturing people into your PLM change management system, but not give them enough licenses or enough capability to manage all of the tooling and process documentation and operator training change and all of that, it's going to fail, because they need to be able to manage that level of detail. And so that's where we would see a plant would handle just the product piece in there, but they'll have their own whole separate change management system kind of tied back to that product change over here that handles the great wealth of detail that they need to manage to get this change right. And that's okay, as long as you can keep everything in sync.
Yeah.
You just mentioned change management being super important, and we know that this has to tie in with all the rest of what's happening in the product lifecycle, right? So how do companies make sure that the updates, the modifications to designs, everything that's happened in this change management are reflected in the manufacturing process and documented?
So typically there are some gate level reviews on that change management process. Your plant managers and your product engineering leaders and your materials leaders are going to be in tune to that. They need to be aware of the level of change happening in their organizations and how effectively that's happening. If you are making promises to your customers and you can't deliver on those promises, you should be counting that against your customer delivery metrics. It should be very visible in your KPIs. So each of those leaders need to be involved in that process and know how effectively it's happening. It shouldn't be a surprise that if something isn't taking place on schedule, or if you're getting changes partially made, and because in the end, you're going to either have a quality issue with your customer or you're going to interrupt delivery.
Yep. So what strategies have you found effective in ensuring that all necessary aspects of a process change are addressed, particularly in your complex manufacturing environments? Plus, do you measure change? And if so, how do you measure that change?
You need to have a detailed process. It needs to be documented. And the people using that process need to understand their role in it and the criticality of it. And typically what I found is people really work hard to make sure that changes get made on time and that their inputs are, that they can make proper evaluation of the change. And so the way a change would come in, you would get a notice of the change and an explanation of what was going to change. And each of those groups, the materials team, the manufacturing engineering team, they would all have a chance to provide input and say, well, I need to order tooling and that's going to take me 6 months to do, or I need to do all this work, or to get the parts sourced is going to take me 3 months, and so I can have the parts sourced on this date. And typically there's a point person, a change coordinator, who's gathering all those inputs and said, okay, based on what you've told me, here's the date we're going to make the change. Everybody be ready. And then they'll periodically have a check-in as you move through that to say, is everyone progressing, and is that change still going to be on schedule, on target? So you need to have a point person who's actively managing it in that system to keep it on track. And they need to hold each of those groups accountable for delivering.
Yep.
I think at this point, it's pretty clear to anybody watching that you know what you're talking about. So just to give you maybe a chance to brag for a second here, can you share a success story that you have had with MBOM?
A success story with M-bombs. We had a time where we were trying out some new tools, and so we set up a process flow to pull bombs and models in that were pre-production for a new product, and we were looking at how can we try out some of these new CAD tools, especially to design our processes. So, we had the bomb, we had the models, and built a full-blown simulation. And we actually found that the way the product was designed couldn't be manufactured. So rather than buying a bunch of equipment and trying it out, we were able to recycle that design on the front end well before we got to the stage of spending money, which was a huge saver.
Kinda.
Huh?
Maybe if you got involved earlier, it would have been an even better saving, but there we go.
No, but our typical way of operating would have been, you look at it, and as much as you can tell from the print, you get that feedback.
Yeah.
But you can tell so much more when you have a 3D model and you can set it in
Oh,
a 3D
yeah.
fixture with a 3D robot to see how does it really go together. And we
Yeah.
found some real problems that just weren't workable.
Right.
I've also seen some successes we've had with systems around M-bomb. So when we implemented a new MES system, we always had built typically back in the day off of paper documents. With just a long list of 1,000 parts arranged in workstations and so forth. And that system was very clunky and hard to maintain. And so when we implemented the new M-bomb system, we had the ability to make changes, not so much the bomb content itself, because that was fixed from product engineering, but we were able to manipulate where it was showing up, like what workstation. So if you were an operator in workstation 52, the old system was so hard that the operators just gave up trying to get parts moved where they should be showing up in the paperwork, and they would just flip back and forth trying to find what they knew they needed to know for their work. Well, with the new system, it was much more capable. We were in the days of modern PCs now. We were able to, fix things just at the drop of a hat. So suddenly, the team was deluged with operator requests saying, hey, can you take this part for this product and make it show up in station 54 instead of station 52? And in the course of probably 2 weeks, we had a lot of those kind of errors flushed out. And suddenly the operators had the data they needed on the screen in front of them, and they weren't having to go search for it.
Yep. That's great. It's great. So rapid turnaround of errors. I get. How do you deal with those kind of discrepancies between management expectations and actual outcomes resulting from that kind of divergence from the official M-bomb system and then into the reality of the working copy?
Well, you need to explain to management what you're doing and why you're doing it. So if you have a set bill of materials and you're going to deviate from it, you have to have a reason for it. And somebody needs to approve that deviation. So it needs to be going up to either the quality director or the manufacturing engineering director. If it's a critical component, product engineering would need to sign off on that deviation. So we would have different levels of sign off and different rules for sign off depending on what type of deviation it was. So those need to be very, very visible to management, and you need to track how many of those deviations you're making. And if you have just blanket deviations that are applied all the time, which we did have, or if you're writing 10 new ones every week, that's a big deal, and it causes a lot of disruption to the organization. And so that's when you need to step back and look at the root cause of all that and say, is my change management process fast enough? Is there some fundamental quality issue that's affecting my product that I can't get this right? Is there some fundamental materials issue where I'm not getting the right materials in and I don't have my supply chain plan where it needs to be? There's got to be some root cause that's causing all of this churn, and getting management support to step in and address the cause rather than just trying to band-aid it with deviations and backward changes is the right thing to do.
Yeah, good.
If there's a company out there that wants to enhance their M-bomb creation, their process planning, their change management processes, what technologies, what tools do you recommend?
There's lots of PLM suites that are capable of this. So I would look for if you're thinking particularly the MBOM, I would look for a PLM or process design system that can take into account all of that manufacturing engineering work, and then one that will then integrate with an MES system, because the MES system is where it comes into play on the shop floor and is going to help you make sure your operators have the information they need. It's going to integrate with your equipment so it can download recipes and specs and other information into your equipment for that product at that time. And, we've been doing that since the early 2000s because that was what we needed to do to get our quality right. So looking for a system that'll handle all of those different aspects in a relatively seamless flow is where I would start if you're starting from scratch. If you got legacy equipment you're working with, you need to take a look at your processes and figure out where your biggest issues are and start there. Maybe implementing an MES system that you can feed your manual MBOMs into for a period of time until you can get the upstream integrations worked out. But there's a lot of different options.
Yeah. Kind of start with a manufacturing execution in some respects, because it gives you that plant leadership as a good start point. Yeah.
Yep.
Can you provide any examples of how an MES system has been successfully integrated into manufacturing processes so that it's been able to enhance that MBOM creation and change management? And if you can, what were some of the challenges? How did you overcome them? And did you see measurable returns on it? Big question.
So integrating an MES system into that whole process flow?
Yeah, and a specific example of how an MES system has been successfully integrated into the overall process so that it's enhanced the MBOM creation and change management.
What we found is in deploying MES systems, the BOM is critical. So just the fact that you're talking about an MES is going to force you to go back in and review your BOMs. And even if you're not working in the MES directly, make sure they're accurate, because it'll either slow your project down or grind it to a halt if your BOMs aren't accurate, because the MES just won't do what you need it to do. But once you've got that in, you've got a good data coming in, then you can organize your process around that data very, very well, and know that you are executing against your data. Again, the critical thing is to have the MES configured accurately and keeping up with change. But once you can do that, you can add all sorts of interlocks and fail safes. And we saw a step function, an order of magnitude change in quality improvements from implementing an MES that was based on the MBOM and integrated into the process, such that you could verify that the right part went on in every station, the right number of tool clicks or your torques on your cap screws were accurate for 5 bolts for that part, those kinds of interlocks.
Were you able to measure the kind of returns, or was it just pure efficiency that you saw?
It's quality for us. It was quality number 1, operating efficiency number 2.
I'm sorry, number 2 was
operating efficiency. And you have to be careful in the operating efficiency, because you can overcomplicate an operator's life too. So that it can be an MES can be a double-edged sword there. You have to be very careful with that. But it can give you some really good data too at the same time to say, here's where your quality issues are originating from. Here's where your where you've got a station that your cycle times are from. And a SCADA system can give you a lot of that same information. So there's a lot of ways to attack it. But an MES allows you to tie it back to the BOM and get that really accurate traceability data. And traceability is the other, it still ties into quality, but it's the other reason for me to use an MES, because you can then link your part serial numbers back to your product. So if you've got a supplier that calls you and says, hey, I sent you a bad batch of material, you can look at that batch number or that specific serial number and say, okay, here's the products it went into. Then you can campaign 100 products, or you can campaign 10,000 products if you don't have that information. And that's where the cost can be enormous between the two. And there's some real cost savings to having that.
You bet. Great.
No holds barred here, but what are some of the common pitfalls and mistakes that you've seen companies make when trying to manage MBOMs with trying to do their process plans? And of course, how can those be avoided?
Well, I keep harping on change management, but not taking change management seriously, I think is a big one. You need to have a good, strong, robust change management process, because it's not having a process set up once, it's how you manage it over time and how you evolve it and change it. You know, if you're in an industrial equipment sector, your products are going to change constantly, and you have to be able to keep up with that. So that's a big one. Not investing in adequate systems and staff to support them. I've seen some engineering teams just completely overworked and just in firefighting mode constantly because they only had resources to do firefighting. So nothing ever improved, nothing ever got better because all you ever did was firefight. And they really needed to have a couple of resources, be able to step back and think proactively on how do we prevent these things from happening rather than let them happen in the first place. And there's great tools out there. I'm a huge fan of PFMEAs. If you use them wisely, they can avoid all kinds of problems for you, but you need to take the time and effort and integrate your learnings back into them so that they can drive real results for the newer products. The other thing for me, though, is not measuring performance. You need to know if you're winning or losing at the end of the day. And that comes back to management. The management team has got to be responsible for that, look for those numbers and act on them.
Can you share a example again of a situation where that inadequacy of system or staff hindered MBOM management and how you overcame it?
Well, we've had a number of, as we were deploying MES systems, we've had a couple of projects where MBOM management came up. I had one plant that put temporary employees on managing their MBOM, and that was a utter failure because they didn't understand it well enough to get it accurate. And so we ended up pausing that project until they could get it right. We had another one where we lost a manufacturing engineer who was core to the process, and it took them 6 months to backfill. So that project just stopped until that could happen. So again, having the right resources in place and be able to configure things correctly is just critical, because it's a garbage in, garbage out. If you want your systems to deliver the quality you expect, you need to put the time into setting them up and configuring them correctly.
So having a great system with bad information in it is just not worth it.
That won't work.
So where do you see us going in the future? Where is MBOM creation, process planning, change management practice, in the industrial equipment sector? Where is all of this evolving? Where do you see us going?
So where I see this moving to is this concept of the digital thread, which we've talked a little bit about, linking all of these different processes and working groups together to deliver the product through its life cycle. And that coupled with the concept of the digital twin. So if you think about a digital twin, an asset twin in its purest form is really a CAD model of a part or a machine or a piece of equipment or a product. We are now extending those digital twins to process twins. So you can take the product and put it in the CAD model of a product and put it in the CAD model of a machine. And now you can see how they interact together. And we've seen a lot of success with those just in measuring clearances, if nothing else. You know, we've put our lines into a CAD model of our plant, and we found that, hey, there's a column right where we thought we were going to put that machine. That's not going to fit there. Yep. That true story. So if you're not using digital twins in that asset kind of way, this is basic technology. It's ready to go. You can get value from it today. Yep. Once you can do that, you can move into a process twin where you're beginning to simulate your process. So looking at that process simulation that your industrial engineers put together in terms of where are your operators, where are your machines, how are they running? This would have solved my problem with my robot cell back 10, 15 years ago, of being able to see how things flow, where they dwell, what the cycle times are, and are you getting your efficiencies out? And then if you take that to the fullest extent, the performance digital twin is going to take your actual data from your running process, feed that back into your process simulations, and it'll tell you, here's how I really ran against the simulation. Where did it agree? Where did it diverge? Where do I have problems? And it's going to let us tweak and optimize. And then once you've got all that working and you've got those links set up between your simulations and your equipment, you can do really cool stuff. Like you can do robot programming in simulation world and then download it to your process. And, you can set up your AGVs or your mobile robots that are delivering material between cells. And, all of these things become possible once you've got your digital twins set up.
How are you seeing the digital twin impacting MBOM?
I think the digital twin is an extension of the MBOM. At this point, we're not talking about just a bill of material, a list of parts anymore. There's a whole suite of information that goes along with it. That part is still the driver because it's still describing the product.
Yep.
But to that product number, you're adding all of this other information that is the full description of how you go about producing that product and testing that product and validating that it was built successfully. And then what you can also do is think about that product as it goes out into the field and it's performing. And maybe you've got telemetry data coming off of that, an IoT system. You should be able to compare that performance to how did it perform in its testing in the plant, or how did it look through a lot of your validation processes. Was there some anomaly in your validation processes that now is showing up in the field and how it's performing for the customer? Is there something there that you can tweak in your process to improve product quality for the customer? Those are all areas that we are going to begin exploring.
In terms of digital twin, which I guess even 5-6 years on, it's still arguably longer than that. It's still relatively in its immature stage. Are you seeing any benefit today from modeling every piece of equipment across your entire plant? Is that worth the time and effort, and will it deliver the return on investment? Or do you want to keep that digital twin just a little simpler than that to deliver the ROI? What's your view on that?
I think you need to model it to the point where you see value and model the parts where you expect problems. I think modeling it to the nth degree, if you're going to be in high volume manufacturing for a number of years and you're producing, if you're one of the big automakers, and then sure, you're probably going to want to do that. But I don't think that answer is for everyone. I think model your most critical pieces, and where you'll learn pretty quickly what you get value from and what you don't, and continue the areas where you see the value.
Great answer. Thank you so much. Really appreciate your time and coming to join us on the Critical Thread series, and you've taken us into manufacturing. Much more to talk about. Thank you again.
Well, thank you for having me. I enjoyed it.